make a little note here that changes that are made to the outside of any of our functions will always affect the graph vertically. In other words, it will change the y values that are used for the graph. Here we are asked to graph y equals 4 times cosine x. So we notice that we have multiplied the outside of the function by 4. So in this case, a is equal to 4. And remember that this is going to change the amplitude, and so we'll say that the amplitude here will 4. It's going to stretch our graph from the middle to the top and from the middle to the bottom by a factor of 4. So we're going to say the amplitude here is a positive 4. The period of the graph, for now, not changing, still 2 pi. So when we look at graphing this, we want to think about our original basic shape of cosine. It starts high, comes back to the middle, goes low, comes back to the middle, and then goes high again. Thinking about this as the middle of the graph, or that x-axis originally. So the original amplitude was a distance of 1. So all of those distances were 1. Now we're being stretched to a distance of 4. So we're going to start high again, but we're going to go up 4 units to start. So now that vertical distance from the middle to the top of the graph is now 4. We're going to come back to the middle at 0. And then usually we go down 1 unit from the middle for that middle point there at pi. But now we're going to come down 4 units. So our y value now will be down at negative 4. And then we'll come back up to the middle of our graph, 3 pi over 2 at 0. And then the last point is supposed to be 1 unit up originally, but now we know that's stretched to by a factor of 4, so it's up at 4. So the cosine graph stretched by a factor of 4 will look like this. So notice that the distance from the middle to the top for each of those places is 4 units long. And then from the middle to the bottom of the graph to that minimum value is also now 4 units long. For the next example, we have y equals negative 2/3 times sine of x. So we have multiplied the front of the function, or the outside of our function, by negative 2/3. So for this example, a is equal to negative 2/3. And we know that the result of multiplying on the outside will be a change in amplitude. This time, the amplitude is smaller than 1. In other words, it's a fraction that's less than 1. It's 2/3. So the distance from the middle to the top of the graph will now be 2/3. And remember that the amplitude is always considered to be a positive value, so we're going to take that a, and we're going to take the absolute value of it. So that just tells me that the distance, that positive distance from the middle to the top and from the middle to the bottom, will now be 2/3. The period hasn't changed. Still 2 pi units to complete 1 full cycle. So originally we would go up and down from 1 to -1, but 2/3 is about right there. So now the graph will bounce between positive 2/3 and negative 2/3. So let's first think about the graph of sine and what it looks like originally. Starts at 0 and then goes up to 1, comes back down to 0, goes down to -1, and then comes back to 0. So the original graph looks something like this. We have 2 things that we want to think about. First of all, the original distance was 1, but now we know that that distance is going to be 2/3. Another thing was the fact that a was negative. And if a is negative, then the graph should flip upside down. So let's think about what it would look like if we flipped this graph, or reflected it through the x-axis. In other words, all of the points that are on the x-axis would stay on the x-axis. So the first, third, and fifth points would stay the same. But any point that's up above the x-axis now will come below the x-axis, and any point that's below now will come above. So the graph of sine is going to flip upside down. And we also know that that distance from the middle to the top and from the middle to the bottom should be 2/3. So let's actually graph this on our graph paper here. At 0, we're still at 0, so we're going to stay there. For our next key point, we're going to come down. Instead of going up, we're going to go down because of the flip. We're going to go down 2/3 units. So that distance from the middle to the bottom now, 2/3. And that puts us at a y value of negative 2/3. For the third point, we're going to come back up to 0. For the fourth point, we're going to come up to positive 2/3. So we have that 2/3 distance from the middle to the top. And then for the last point, we're going to come back down to 0. So we have our sine wave, 1 period, flipped upside down. And now with an amplitude of 2/3 for the graph.